Zoom changed a few things, so.
Hello everyone, and thank you for joining us on the latest SpaceUp Live. This time we'll be looking at all things about preparing for space, and that'll be from mission design through qualification testing to astronauts. And yeah, we'll explore this theme throughout the course of the evening. So apologies for the technical difficulties there, so we started a few minutes late. But we should be good to go. So again, thank you everyone for joining. We've got a few people with us, so let's kick things off. Your host today, as usual, is myself, Ryan, my colleague Ryan Laird, and of course Remco. So, the organisers of R&R Space is, the organisers of SpaceUp Live is R&R Space, and we try and do events, get people talking and interested about space, from networking to general interest and training and new event concepts.
This event would not be possible without HE Space, and we have an interesting talk later from HE Space and preparing for your space career. So join us as we hear about how you can prepare for your own space career.
16.
So we've got a jam-packed lineup for you tonight. We're in the welcome introductions part of the evening, and then we've got a keynote from Loretta, followed by a talk from our sponsor, who'll be letting you know how you can prepare for your career in space. Followed by an exciting panel session discussing about all the different ways that the space industry prepares for space. Fantastic set of panelists tonight, and then we've got some user-submitted T-5 talks and grid sessions. There'll be plenty of time, as always, for everybody to answer your questions that you have from the various sessions. And we'll aim to wrap up around about 20 past 7 this evening. So several different session types. The panel sessions are, as you'd expect, 4 panelists. We'll start off by asking them a couple of questions. And if you've got any questions for the panel, drop them in the YouTube stream chat and we will pick out from them. Do preemptively type your questions, because there is a 30-second delay between what we see from our end or coming through on YouTube and the chat and what we're actually saying. So get your questions in early for the panel and the Q&A sessions as well. Then we've got T-5 seconds. Now, these are very fast-paced talks. They are 20 slides long, 15 seconds per slide, and the presenters do not get a chance to slow down or stop or go back. So they've got to keep the pressure on, they've got to speak quickly, and they've got to get their point across. So high-pressure talks. And then we've got grid sessions, which Ryan will explain what they are.
So grid sessions can be any kind of talk. So it's a 15-minute slot. This could be a particular talk or maybe even a bit of a pop quiz or Q&A, any kind of format that you wish to talk about. So we have a couple of interesting talks that you'll hear about shortly. And our keynote for today is Loretta Whitesides. So Loretta Whitesides is a founder of SpaceKind, so I'm sure you'll hear more about this. Also the co-creator of Yuri's Night. So if you ever want to party about space, we have it's very important anniversary, 20th anniversary of Yuri's Night this year, as well as the 60th anniversary of Yuri's own flight. And Loretta will talk about how she's preparing for space as a future astronaut. So hear more about this in her keynote. Next, we have our sponsor at HE Space. So preparing for your own space career. So so check this out as well.
And of course, our panel, we're going to be talking about how preparing for space, and it will explore how satellites, rovers, and humans all prepare for space exploration. We'll touch on a few different areas around this, around mission design, in situ testing on Earth, operations, testing, and of course, astronaut training and launch. So again, get your questions prepared for the panel. We've got a few questions of our own, but ultimately, it's up to you guys to ask some questions about what you want to find out from our great host of panelists. And our panelist lineup today is, we've got Hannah, who's an industrial placement engineer at R&R Space. We've got John Chinner, who's a faculty leader at Airbus Space and Defence. You've got Olivia, who's a board member and head of social media for the Austrian Space Forum. And we've got Thomas from Central One spacecraft operations engineer from the European Space Agency. So you'll be hearing from all of those later.
So our T-5s, we have a great lineup here with Charlie Bilzan talking from Powering Space. So if you're into space communication outreach, this is a conference for you, talking about the Impulse conference taking place only on the 9th of April. So actually just over a week away. We have Vicky Dunkov, who's the president of the Space Tourism Society. Interesting to talk about there from Vicky Video, and also Nishal Chand, who is going to talk us through his new moon rover concept. So stick around and hear about those.
And we've got two grid talks happening today as well. And we've got Narayan from Sat Search talking about space for equality and inclusion. And we've also got Dame Commander Dr. Susan Ipdwell from the Mars Moon Astronautics Academy and Research Sciences. So that'll be an exciting talk there as well. So shall we kick things off with our first keynote talk? So Loretta, I'll stop presenting and over to you.
Fantastic. Thanks for having me. This is fabulous. So I'm going to go ahead and do my screen share and then find the right screen. Do share sound, optimize, all the good things. Okay, can you see Yuri's Night on the screen?
Brilliant.
Thanks, Remco. Perfect. So let's start off with that, because that's at the top of my mind, because it's in a week. And I'm super excited because it's our biggest Yuri's Night ever. We're doing a global live stream all around the planet, kicking off at 3 p.m. Pacific. So it's almost reasonable in the UK for your late partying owls. I love it. And though the back end that we're using, we have for 24 hours. So we may just be that we invite the UK events and the Moscow event. I'm really excited. One of our ISU alumni is hosting a really cool Moscow event with lots of cosmonauts, and have them all in the back end as well. So anyway, we might be an all day thing that you can join in. So that would be really fun. Wait, I have to click. Oops. Okay, that worked. Okay, so that's me and my husband George. We were only colleagues when we started Yuri's Night, and a year into it, I asked him out on a date, and that went really well. So now we're married. Yuri's Night celebrates the conjunction of the anniversaries of the first human to go into space, Yuri Gagarin, and the first. Wait, that must have been the last. Oh, there it is.
Sorry,
yeah,
Loretta.
the first. Oh, go ahead.
Sorry, Loretta. Could you go full screen? Sorry.
Oh, I'm not at full screen?
No.
Okay.
Just at the bottom, yeah. The view, yeah.
Sorry, it's full screen for me, so I can't even see what you can see. Let me.
It's not in present mode.
Not in present mode.
Just go to present mode at the bottom. Sorry.
Okay, so you see like all the slides, right?
There is a play button. You can click on it.
Okay, so I hit
On
play,
the right side.
and that's what it does. Is that what you wanted? Or does that work better? Or did I hit the wrong button?
It's at the very bottom.
On the right side of the
Oh, like this one? No, that did not do it. I don't know.
There's a little button, slideshow button.
Yeah, I hit
upper
slideshow.
side.
That is what I'm hitting, so that's why I'm confused why you're not seeing.
Okay.
Yeah, you probably have two screens, and what you see is what you should share. You shared the other screen.
Okay, so let me stop share. And you're saying I should pick in the screen share.
That is the full screen one. Yeah.
Let's try Microsoft PowerPoint. Space. Okay, let's try this one. And then I'll hit screen. And does that look better?
Ah, yes. There we go.
Oh, it looks better for me too. Okay, I see what you're
All right.
saying.
Okay.
Okay, so yeah, so then the first space shuttle took off April 12th, 1981. 20 years later to the day after Yuri's historic flight. And we just got video for the first time from the commander, the pilot of STS-1 saying, yeah, it was just a coincidence. We weren't even paying attention. We weren't trying to do that. It's kind of funny. Anyway, in 2001, we started Yuri's Night. So it's our 20th anniversary this year, big party. This is our event in 2007. It was a huge rave at NASA Ames in Silicon Valley, which was really fun. It was like Burning Man meets NASA. In 2014, after the shuttles retired and moved to LA and Florida, we started hosting events under the shuttle. I'm a big Star Wars fan, so I like to throw in my cosplay, my costuming, I like to throw in some Star Wars. We had Buzz Aldrin come in 2016, which was super fun. And then last year, because of COVID, we had to take everything online, but that made it fun because we could have people like Chris Hadfield just beam in from Canada, Soyun Yi beam in from Seattle, and Scott Kelly and Bob Weir of the Grateful Dead could just hang out in their living rooms, drinking beers and talking about space music, which was phenomenal. We had Bill Nye show up. It was just a great event. So at the very end, my end slide is about how to get involved this year, get tickets, or just watch the live stream. Or if you need to go to bed, you can watch the live stream the next day. But we have an incredible lineup. We have Bill Nye's going to be back. We've added Sir Richard Branson, which we're really excited about. We have a slew of astronauts. We have the ESA astronaut, Luca Parmitano, going to be hanging out with Richard Garriott. They're going to be swapping space stories. They're going to be doing like a drinking cocktails, swapping their, oh, but remember that time when you almost drowned in the spacesuit? So that's going to be super fun. We're going to have a UK future astronaut for the Virgin Galactic, Trevor Beatty, who's, I love him. He's one of my favorites. He's going to be on with NASA astronaut Katie Coleman and National Geographic explorer and woman who summited from Bangladesh, who summited the 7 summits, Wasfia Nasreen. She's amazing. Am I talking way too fast? I'm trying to get everything into 12 minutes. So, okay. Let's see. We also have OK Go, the band. They did a flight in 0G and they filmed a music video in 0G. So we're going to be giving them the Spirit of Yuri's Night Award. And they're going to be showing a new video we helped them create with submissions from around the world called from their COVID song called All Together Now, which we're really excited about. And then the after party, we have the twin sisters from Australia, fabulous world-class DJs going to be spinning for our after party. So come buy tickets to the back end so you could be a part of all those things. We're going to have Space Jeopardy and meet and mingle, a chance to you can pick between your tables who you want to go hang out with. I want to go hang out at Remco's table. I want to go talk to Everyday Astronaut. And so you can sort of bop around and all kinds of fun stuff like that. So anything else on Yuri's Night? Dun, dun, dun. And the cocktails, but that sounds right. Okay, so in the theme of preparing for spaceflight, I also wanted to share some of my other crazy, cool adventures, which is I worked for Zero Gravity Corporation part-time on the side. It was sort of a weekend thing for 10 years. And so I got to do 80 flights on our plane. That's obviously upside down, but it gives you a sense of the weightlessness. That's me with my mom, with my Yuri's Night patch, floating weightless. And this was our biggest flight ever, flying Stephen Hawking. So it's an incredible way to prepare for space. And as somebody who's going to space, probably not really in the next 2 years, I find that my weightless time really helped me feel comfortable with knowing that I have my sea legs. I know what to do when I'm weightless. I've also been to the bottom of the ocean with Titanic and Avatar director James Cameron on these Mir submersibles. We went 2,000 meters, no, 2 miles down, 5,000 meters down. This is the sort of near the Azores on the Mid-Atlantic Ridge, sort of near you. It was a ton of fun. So that was another great analog. It was a small titanium sphere with a Russian pilot. It was just like a Soyuz. Come on, it was awesome. And it was totally death-defying too, because a lot of the analog missions, NASA sometimes does analog missions like in the basement in Houston. And I always say, no, that's not an analog, because if you cut your finger, they're just going to open the hatch and take you to the hospital. But when you're in the middle of the Atlantic Ocean, you're not going to see anyone for days. Not even the Coast Guard could get to you for 3 days, or the Navy. So you really, as an American, it was my first time really understanding what it's like to be off the grid and out of rescue, out of far too far to be rescued, like no helicopters or anything. So anyway, so I have a ticket to fly with Virgin Galactic. I'm going to do a suborbital flight. This is our hangar in New Mexico, which is gorgeous. It looks like it should be in a Star Wars movie. And that's one of our old powered flight pictures. And so this is the way I tell people to prepare for their flight. We have about 3.5 minutes of weightlessness at the apex of the parabola when we're up in space. And I tell people the best way to practice is to just spend 3.5 minutes every day in your living room, just being totally present and overcome with awe at just the tree out the window and the air you get to breathe and the gravity holding you to your chair, and just every sense just fully just taking it all in instead of numbing it out like we normally do, just like the way you would at the window of a spacecraft, just like savoring every sensation every second. And I think that's the best way you can prepare for space. I also teach a class on preparing for space called Space Kind Training. Teach people to dream big, to ask for help, and to never give up, because space can be hard. It's like Jedi training, but without the copyright. And we like to say that the most complex system of the spacecraft is the people that's building it, because in all our engineering classes and all our science classes, there were no equations that could help us figure out how to work things out with a colleague that aren't going well, or how to resolve differences on the team. And I find in my career that that's the hardest part of rocket science, and the part that really has caused a lot of failures and crashes in our industry. So that's what we work on. We train people, and everything you do matters. The way you show up in a Zoom call, the way you look in the video and like talk to people right in the camera matters. Your energy level, the words you pick in an email, the way you acknowledge people, learning people's names, everything you do matters. And so really taking care, like the future of humanity depends on it and you, because it does. We also, as an example, have rules like don't throw anyone under the sand crawler. It's a small industry, it's a small planet. We got to take care of each and every, got to look after each other. So our next new Not Right Stuff training, thanks to COVID, it's now online and available to the world. The next one starts on May the 4th, because obviously I'm a huge Jedi fan, and it's 8 Tuesdays. They're pretty late this round. They're 5 p.m. Pacific, so it's not great timing for Europe, but I alternate. The next round, which will probably start in August, will start at 12 noon Pacific, which is 8 p.m. UK time, which is, could fit more schedules, I think, in European time. So keep your eyes open for that. You can go to spacekind.org to sign up whenever I get those dates figured out and online. And then, as promised, here is the slide to help you go to yurisnight.net/livestream to get your tickets, or to set the reminder bell on YouTube to come back and watch the live stream next Saturday night. And we're super excited for this epic event. And we hope that lots of you folks in the UK and beyond, whoever's listening to this, I'm sure there's people all over the world, can join in the Yuri's Night movement and help us celebrate the power of space to bring the world together. So thanks for having me, and I'll open up for questions.
Thank you very much, Loretta. That was a fantastic talk. We did have a question in the comments, actually, from Space Girl Heidi, and the question is, what is the easiest and hardest part of being a female astronaut?
Oh, that's a great question. Well, the easiest part is that you're easier to remember, because you're 1 in 50 instead of 1 in 500. So I find that to be a great advantage at a conference, that if being the only woman in the room, that they remember, oh yeah, I remember you, you're the only woman in the room. You're like, yeah, that's great. So I find that to be the easiest part of being a woman astronaut. And the hardest part, I think it's interesting, because I remember when I first got to university, there was orientation, and they sat us down and they warned us that as women, we've been overlooked in the math classroom, and it's we've had this difficult time. And I remember thinking, no, not me. No, I didn't have that. I didn't have any of that experience. Like I'd always, I'd gone to an all girls high school, and I mean, we had an all boys high school next door, so we had boys, but I didn't have to compete, and I always felt empowered by all my teachers to go into math and science. And so I'd never experienced what so many people have described of being held back. And so this was sort of a news to me at university that being a woman could be a challenge. I didn't know that. That was news. And what's been interesting is lately, as I'm older, I turned 47 next week. What I find to be the hardest part now is the glass ceiling, is getting to the next level. So I'm really powerful advocate now for having more women in the boardroom, and having more women in leadership and in government, and taking roles, decision-making roles and leadership roles, running companies, CEOs, because I think we need that perspective and that balance to the force, obviously balance to the force. I think the hardest part is getting representation at the highest levels of leadership of all industries, especially ours.
That's fantastic. Thank you very much, Loretta. I can't see any more questions in the comments. There's a few compliments. Nice presentation. People enjoyed it. So thank you. I guess next up then we have HE Space. Ryan, do you want to do the introductions for that?
Yes.
Yeah, so this event is being sponsored by HE Space, and we're looking forward here to a talk by Agnieszka Iwanchuk, who's a senior recruiter. We look forward to hearing more about how you can prepare for your own space career. So yeah, Agnieszka, over to you.
Okay, welcome. Hello, everyone. Can you hear me?
Yep.
Yeah, let me, I have a presentation that I'd like to share with you. Let me do it first. There we have. All right. So again, welcome. My name is Agnieszka. I'm one of the recruiters, talent acquisition specialists for HE Space. And indeed, I'm here today to introduce you to HE Space, provided that you don't know us yet. It's a little bit weird to be online. 2 years ago, we were there live to meet with people, and this is much more fun, but well, it is what it is. So I guess we have to take it like that. So who we are and what we do. HE Space Operations is a privately owned recruitment company. We are on the market nearly 40 years, and our main area of expertise is space. So in fact, we are space recruitment company, manpower company with recruitment services. At the moment, our biggest customers is by far a European Space Agency with all its locations in Europe. We cooperate with EUMETSAT, the biggest meteorological organization located in Darmstadt. We cover all Airbus locations in Germany, and we cooperate with smaller space companies such as OHB, DLR, Thales Alenia Space. So here you can see where we are actually and where our customers are. So the red color are HE Space offices. At the moment, there are 6 offices. However, the headquarter, let's put it like that, is here in the Netherlands, Noordwijk. We are located opposite the space agency. And this is where majority of us sit. We have 2 offices in Germany, in Darmstadt and Bremen. We have a very small entity in UK. The main reason to open this was Brexit, and basically we had to create a legal entity to be able to hire people in UK, in ISA to be precise. And we open at the end of the year our smallest office when there is just 1 person sitting in Toulouse, France, as we already started expanding the French space market, mainly the French startup companies. And we have also the office in Houston, but there is more, let's say, administrative part. I will get there and I'll explain you why Houston in a second. Here on the blue part, you can obviously see all our customer locations, which is obviously all ESA's locations, the Airbus location, and the UMITED. So we were actually our founder, Scott Millikan, is an American engineer who used to train astronauts for Apollo mission in Houston, obviously in NASA, and he's a author of a sort of manual for the astronauts that you can see here on the picture. So this is how it all started. So that's very much actually space related. Scott turned 80 yesterday. We had small celebration in the office. So well, still going strong. We support in our vacancies all space programs. So human space flights, space science, Earth observation, launchers, navigation, telecommunications. We have jobs in all of these domains. But let me maybe go one step back. Why are we actually? What's the purpose? What's the reason? So most of our customers, such as ESA, Airbus, UMITSA, these are government-owned entities, and the structure of employment is approximately 60% staff and 40% contractors. This has to do with the funding from European Union that this is resolved basically like that. Partly. Approximately 40% of employees need to be hired by external providers, such as HE Space. So we hire those people according to our customer needs on our payroll, making sure that they are happy, that they are being paid. We do all the HR duties. And physically, they are working on site at the customer entity. So we are preferred suppliers for all the contracting jobs. And this is a lot, because as I said, the structure would be more or less 60-40%. We cover, as I've mentioned, all the domains that you can see here, a lot of engineering job, majority. We have some non-engineering positions as well, but this is comparing to the engineering jobs a few. Our jobs cover all the mission phases from, application, outreach, define, design, build, launch, etc. So we are going through all of this in our jobs. What is very good, what is very optimistic is that we are constantly growing. Every year is actually better, so that's amazing. At the moment, we are over 250 employees, with majority sitting at ESTEC in Nordwijk. That's, if I'm not mistaken, from the top of my head, over 150, only here in Nordwijk. So that's great. To be honest with you, we haven't noticed any slowdown in jobs from ESA, from our customers, due to COVID. So space seems to be untouched. It's actually very busy. We are getting a lot of jobs to cover, so that's great. Growing steady, hoping to reach 300 by end of next year, or even earlier, maybe. And what is also very nice to share is that our people are very happy with us. We claim to be people-oriented company. So this is what is the most important for us, that our employees are happy, that we can help as much as possible. Mainly due to the fact that most of people we hire are expatriates, people coming from abroad to Germany, to the Netherlands, UK. So we're making sure that the transition process is smooth, that they are settling down, and when necessary, they are being helped. Here are the details of our offices. I have to admit that most of the jobs, especially at ESA and UMITSA, these are jobs for so-called experience hired. So the certain amount of years of experience is necessary. There are sometimes more junior positions, but let's say percentage-wise, it's much, much less. Airbus is very much open for junior profiles, so this is where we can place people who are fresh graduates or with, let's say, not that significant work experience, because I'm guessing this question quite often, especially for students or for fresh graduates, what are the perspectives? So I'm being honest here that mostly for ESA job, they require some experience. However, we had the cases where people with let's say 1-2 years are also getting jobs. The only necessity is the graduation needs to be completed for most of the jobs at mainly at ESA or UMITSAT. So yeah, this is about us. Yeah, you can once you enter HE Space website, you can go to the tab with our current jobs, which we have open at the moment, which we are actively hiring for, and apply if there is anything interesting for you. What we also are very much open for is open applications, where people are sharing their CVs with us. When we see that the CV can be a potential match for the future job, we are storing it in our database, where we currently have over 7,000 profiles. And there, where we see that there is some nice match, we contact person for this opportunity. So this works that way as well. So yeah, here is about us in a nutshell. Normally, we are very present on majority of the events, such as SpaceUp or all other space conferences, where you can come to the stand and talk to one of us. That's well, a lot of fun, and I personally like it. Now the world has changed a little bit. Hopefully it will come back to normality, and we'll be able to continue that. So yeah, thank you. I know if you have any questions, please feel free.
So I did notice one question in the chat. It's from Space Girl Heidi again, and she says, "Hi, I'm becoming a social marketing specialist in the space industry. Any advice?"
Yeah, we had jobs for the marketing specialist in space industry in ESTEC several times in the past. So yeah, there is such a possibility. Obviously, as you can imagine, it's more a little bit of a niche job, but we had positions for someone who is specialized in marketing with a, let's say, space background in ESTEC in the past. There is a let's say, directorate where they do such things like advertising, marketing for ESA, and they were hiring in the past quite a lot. At the moment, it's quiet, so I believe the people are steady there in their jobs. But yeah, it is a type of profile that we had in our, let's say, within our jobs. So I would probably advise the big entities such as, for example, ESA. There is a bigger chance to land a job there.
That's fantastic. Thank you very much. I can't see any more questions in the chat at the moment, but I'm sure in other Q&A sessions, if people post them and you're still around, then I'll ask you then. Thank you very much. That was absolutely fantastic. And again, check out HE Space website. We put it in the YouTube live stream chat if you want to find out more about how you prepare your career for space. So next up then, if I can find Zoom again. Yeah. Here we go. So next up, we have got our panel session, where again, we're talking about preparing for space. And we've got some 4 great panelists here today. And in your running order, if you want to take 30 seconds to introduce yourself, and yeah, introduce yourself. So Hannah, do you want to take it away?
Hi everyone. Yeah, thanks very much for having me this evening. My name's Hannah. I'm an industrial placement student in the testing division of R&R Space, which is part of STFC. And I'm between my third and my fourth year studying mechanical engineering at Lancaster University. I work mainly in the dynamics group, which deals with pyroshock and vibration testing of spacecraft equipment. And my focus is primarily on the development of our pyroshock capabilities, as it's a relatively new test to us, as well as monitoring machine and equipment health, which takes me beyond the dynamics group into learning about other qualification tests as well. Thanks.
Fantastic. John?
Hello, everyone. I'm assuming you can hear me. I've literally just joined. Great, good stuff. I was having technical issues, you know what it's like. So yeah, I'm John Chinner. I'm an engineer with Airbus Defence and Space. I'm based in Portsmouth. Right now, I am the faculty leader in the Engineering Academy. So my job is to make sure that Airbus has engineers with the skills they need in the future, upcoming technologies and new technologies that are coming to the market that we can use in the next 5-10 years. So previous to that, I've worked as an electrical design engineer, principal electrical engineer, and I was involved with qualification testing and some ground equipment for ships and also ground stations. And I also did qualification testing on the AstroPi Mark I payload. So preparing for space is something I think I'm still doing, and I've been doing all of my career, and I think I'll probably keep doing because every day's a school day.
That's fantastic. Thank you very much, John. Olivia?
Yes. Hello. Good evening from Austria. I'm Olivia Heider from the Austrian Space Forum. I'm a board member there and also head of the social media team within the Austrian Space Forum. And for those who don't know the Austrian Space Forum, or ÖWF, how we call it, we are a citizen science organization and have a strong focus on analog research. So we are doing simulate Mars missions on Earth. So the last one was in 2018 in Oman, where we went with a field crew for 1 month into the desert. And I was one of the lucky ones who joined the field crew and experienced how a human could live on Mars, so to say. And for this year, the next mission is scheduled for Israel. And I think analog missions are perfect a way to prepare for space, especially if we want to go to Mars. We need to train the things here on Earth so that later on Mars, everything works out fine.
That's brilliant. Thank you, Olivia. And last but not least, Thomas, you want to introduce yourself?
Oh, yes. My name's Thomas Ormston, and I work for the European Space Agency at their European Space Operations Centre in Darmstadt, Germany. My job is a spacecraft operations engineer, and I'm Deputy Spacecraft Operations Manager of the Sentinel-1 mission, part of the EU's Copernicus programme. But our job really is to fly spacecraft at ESOC, and that's my thing is flying satellites. I started out for about 7 or 8 years flying our Mars Express mission, Europe's first mission to Mars. But for the last about the same amount of time, since 2012, I've been working in our Earth Observation Division on Cryosat and then EarthCare, which was a satellite that's going to launch, and now our fantastic Sentinel-1 radar constellation. So very excited to be here.
That's fantastic. Thank you, Thomas. So again, there's a 30-second delay between what you can see of us talking and the chat. So if you've got any questions, put them in the chat now. And I'm going to start off and ask the panelists in running order again. Hopefully it was quite an easy question, but hopefully it will spark a bit of discussion. In your respective fields, what is the hardest thing you've come up against when trying to prepare for space?
Personally, I haven't been in the space industry for that long yet, and I haven't had that much experience. But from what I've gathered from interactions with customers and tests, the hardest part for me tends to be working out anomalies. Why have we got this particular result in a test, and what caused that? And can we prevent that in a future test, or is that something that's expected from the test item? Another thing that I would say is challenging, to say the least, is when you're dealing with customers, you have to make sure that the requirements that the customer needs and the capabilities of your test facility align. and that the IUT has the correct interface that you can put it on your vibrating machine or on your shock machine, and that it will stay there, and it won't have any unwanted vibrations that they're getting back. We need to know that whether there's any issues with cleanliness, so it has to be kept in a clean environment, and we can work around that, and whether there's any ESD, which is electrostatic discharge interference possibilities there, so we can also prepare for that as well. So it's interacting with the customers and finalizing the test procedure to make sure that everything is correct and
Right, I'm going to pick up there then, Ryan, because Hannah seems to have finished. So for me, the hardest thing, perhaps, I think, if I think back to the things I've done, the real point where I thought I was in trouble was when I received the requirements for sending hardware to the Columbus module on the space station. I had this tiny little thing, educational payload called AstroPi, that was wanted to send up to the space station with Tim Peake's mission. And I asked for the document that gives me all the information I need to make sure that that payload will be safe when it gets there. And it arrived, and it was 2 inches thick. And it was interesting because it came from the author of the document was a company called Astrium, which ended up turning into Airbus Defence and Space. So everybody looked at me and went, "Well, you come from your company, you must surely understand it." And I realised that going through it, I had I'm an electrical engineer by trade, so I could understand some of the EMC and electrical things in there, but things like shock and vibration, off-gassing were completely new. But I'd sort of stepped forward and said that I would take a leading role in the qualification, and perhaps had to project the confidence to the customers and people around the teams that it was all going to be fine. So, picking through documentation, picking through standards, picking through requirements from customers, I find is really hard, and it's also really, really important. So you got to get it right. Yeah, I always find those things a little bit daunting.
Fantastic, thank you, John. Olivia?
Yeah, it's quite, it's not so easy to answer such a question. There are many difficult or hard things. One part is, of course, in our case, get the funding for this mission, which we are doing, because we are not the government organizations and we are not supported by government organizations. Normally, it depends where we are going. For example, we got a lot of support from the Sultanate of Oman, and we will get also a lot of support of Israel, because they know it's important to do these analog missions, to be prepared for later for space missions. In Europe, I would wish that maybe the big agency or ESA could pick up a little bit up more on the analog research, because we think it's a really important tool we can use for these space missions. Another thing which comes to my mind is also that we tend not to think big. If you do these missions, which we do, we have more than 200 people involved, and most of them are volunteer people, so they don't get paid for the things they are doing, we tend not to think big enough. But you can do big things if you have the right people with the right know-how, and you have people who are really exciting about space, and also go out and talk about these things which we are doing, especially involving young people. I know, I think John is one of Thomas, I'm not sure, I hope I don't mix you up, but you do a lot of outreach and inspire young people, and that's something we need to do, because they are the next generation scientists. And it's also a thing we learned. You can even involve them with analog missions and, for example, with a junior researchers program. So they have to also think about an experiment they want to do, and we can take these kind of experiments also in our mission and do the same experiments as we do with big institutions or universities.
That's fantastic. Thank you, Olivia. And again, last but not least, we'll start with you next time, Thomas. Thomas.
Oh, I don't know. It's good. I get a chance to think about it. No, okay. As I've had a chance to think about it, I would say that for me, the biggest difficulty or the biggest challenge, especially as an engineer, is learning the power of compromise and learning how important that is in what we do, because you're always part of a bigger thing. I started working in operations on one system of a satellite, and then now I'm up at system level and I see them all and I see the compromises between them. But then we're just the operations team. You've got the design team, you've got the people that are looking at the science, you've got the political side of things and things like that. So, and everyone has competing wishes, and as an engineer, you're so focused on finding the perfect solution. And it's so natural that you think, well, if I just do enough maths or write enough documents, I will reach the ideal perfect solution. But learning that that's not always possible, and what the perfect solution is actually the solution that satisfies the most people, is a big challenge to overcome, and one that I've not completely mastered myself yet, but it's something that I think comes into every part of our everyday life at work, and probably in many other industries as well, but particularly in the big complex systems that we work on. Trying to accept what other people's point of view is and where they're coming from, and trying to accept that you're part of a big system, and that your compromises are what makes that big system work is something that I think everyone should remember when they're in the space industry.
Fantastic. And I think those lessons on compromise don't just apply to the space industry, they're wider than that. So fantastic advice there. We've got a couple of questions from the audience. One for you, John. Are AstroPis on the ISS still running? Noticed that the Twitter accounts hadn't been updated since 2017.
Good question. Well, the simple, straightforward answer with regards to AstroPi Mark 1 is yes, they are still there, still sitting bolted to the Bergen arms in the Columbus module, and still being used every year for Mission 0 and Mission Space Lab. So Mission 0 is one of those low bar things where you can actually submit your code to fly in space. It runs every year. And if you're interested in, you've got a young person or a group or a STEM club around you, and they want something interesting to do that isn't going to be too difficult, I'd go to look at Mission 0. It's I think it's closed for this year now, so it's a next year job, but you can get your students to send their code to space, and those run every year along with Mission 0. So those AstroPis are still up there, still working. Thank goodness. It must have been the quality of the qualification testing that was done on them. But yeah, so the project hasn't ended. The project is still going. So with regards to Twitter, if you want to see updates from AstroPi, it's definitely the @astro_pi accounts. You might be following AstroPi Ed and AstroPi Izzy, which were the two accounts that were set up for the individual Pis that got sent to space. To be honest, I haven't seen updates from them for a while either. But if you wanted to cut through all that and get to the heart of AstroPi, it's the main AstroPi account, which is @astro_pi.
That's fantastic. Thank you, John. Okay, so now a question. We're going to start with Thomas, and then anybody else can take it. I'm putting you on the spot here. If you don't have an answer, don't worry. We'll go to anyone who can answer this. Sorry. So, I mean, based on what on your fields, what do you think is going to change, if anything, over the next decade in the way we prepare things for space?
Yeah, so certainly from my field in operations, and particularly in Earth observation operations, what's going to change is space junk, and sadly not in the right direction. Although there are some lights on the horizon. Everybody's probably heard of the mega constellations that are going up. Starlink from SpaceX being the most famous, but Starlink on its own, if they reach the projected number of spacecraft they're going to launch, is going to more than double the population of objects in low Earth orbit just with one constellation, and it's not the only one going up. And it's being approached in a lot of senses with a sort of do it first and solve things later. Not completely, and many people are working on this, but it's certainly a concern because space debris is already a problem. In fact, I almost missed this chat because we had a collision alert for Sentinel-1 just this afternoon, which hopefully nothing's going to hit us. We'll see tomorrow morning. But this is part of everyday life in operations already, is doing collision avoidance, dodging out of the way of things. And it takes a lot of effort and a lot of work. And that's with the population that we've got at the moment. With mega constellations coming, although they present a huge opportunity, we've also got to look at what risk they present and what we can do about the space debris problem, because it's already something you have to design for in low Earth orbit, something you have to operate for. And we really, really need to look at where we're going with that and not make the mistakes in space that we've made with climate change, for example, on the Earth.
That's fantastic. Certainly, I've noticed a lot of articles going around about space junk lately, so it's definitely becoming a hot topic. I'll leave it open to any of the other panelists to jump in with that about that question then.
I was going to add there that it's a funny one for me because I grew up looking at the night sky and watching satellites flying over, and the novelty of seeing satellites in the night sky hasn't worn off. And I love seeing little specks of light, knowing they're human-made machines that are up there operating. But the first time I saw a SpaceX chain of satellites going over, I suddenly thought, hang on, this is different. This is a real change here. This is space isn't crowded by any stretch of the imagination, but there's definitely going to have to be some hard conversations about this because you equate it to climate change, and I guess humans have already shown their ability to ignore the problem until it really becomes a really big problem. And unfortunately, I think this is probably going to go the same way. That there's no single regulator in the globe saying that you have to operate these things and be careful. And unfortunately, by the time those kind of regulators are stood up, it's going to be too late, and there's going to be collisions. The end point for these things is really, really bad. So the risk is getting higher, and the damage is going to get worse. So it definitely needs to be considered. And I'm glad there's so much being talked about in the public domain about this. Because it's a really, really critical thing.
Brilliant, thanks, Sean. Okay, if there's no more thoughts on that question then, Remco, did you say there was a question from the chat?
Yes, John Swift, he was initially asking this to Agnieszka, but I think Thomas can answer this as well. He's saying, as a recent master's graduate without much experience at all in spacecraft operations, etc., there are fewer opportunities for training as I'm no longer a student. What would be the best way to get it now?
You see, I'm catching up now with the questions. So it's a very good question, and it's the paradox that everybody, including me, faces when they want to get into operations, because pretty much no one learns operations at university. We learn design and things like that, but no one learns what operations is or how to get into it. There are a few ways to get in after your master's. Look at graduate programs like the YGT program that ESA has. That's how I got into operations. But also look at ways you can get in, maybe not as a spacecraft operations engineer, which is the job I'm in, but something like a spacecraft controller, which is a slightly lower position, but actually a really good graduate starting position, because you're there dealing with the spacecraft every day and looking into it. So that's what I would suggest, is just to shop around and look at the jobs that are maybe they don't feel that, maybe they feel beneath you. They're absolutely not. They're a key part of the industry. They're very exciting to do. And once you're in, and then you can work your way up. But that's always the issue with a lot of areas, I think, of the space industry, not just operations, is breaking in takes quite a bit of perseverance. You may end up with quite a few rejections, but I promise you it's worth it, because if you persevere, you can get a really exciting career out of it.
That's brilliant. Thank you very much, Thomas. I don't know whether you've got any more questions from the audience, but in the meantime, Olivia, a question for you. So obviously you do some great work with the analog research missions. If you had a bigger budget, what would be the next step in order to prepare people to go to Mars?
I think we would go more remote to more remote places. So at the moment we stick around Europe, I would say, because it's also feasible for us to do, and there are a lot of nice places to go. If I may share one image, maybe, I'm not sure if this works out. Just that you get a feeling why we can do that on Earth. So, and sharing is over here somewhere, I suppose, or not. Maybe you can point me here to the right direction. Okay, so for example, there's a comparison of one picture, Oman and Mars. The above picture was taken in Oman during an EVA with our spacesuit simulators. So these spacesuits we are building ourselves. So it's our own technology, our own know-how inside, and we say it's a little spaceship to wear, for example, because you have everything you need in there, your own ventilation, onboard electronics, and so on. Of course, also you have something to eat and to drink. And the picture below is taken from Mars, from probably curiosity, I would say, at a similar time, say in 2018. And this shows you that on Earth we have really these perfect places to go where we can learn how to do things right later when we go on to Mars. And what we would love to do if we would have a bigger budget is, of course, to go more remote places. For example, one big on the wish list would be the Atacama Desert, because it's also from an astrobiology perspective, it would be ideal place to go there because there is not many vegetations and hardly any things who live there. A lot of studies from the Atacama Desert, from the astrobiology perspective, that it's really, really interesting. And we would like to go there and test if we could find life with the experiments we are using. So maybe also one other thing, the experiments we are doing in these simulations, there are some made by our organization, but most of the experiments are done by partner institutions or research institutions. So we always have an open call for experiments. So different institutions can go with us, can use us, because we are doing all the organization and bring everything to the place, and they can use us, bring the experiment there, and we will conduct then the experiments. So for example, we had a greenhouse experiment from the Italian Space Agency in 2018, and we could grow, so to say, some food, fresh food, also in the desert. So that was really, really nice.
That's fantastic. Thank you very much, Olivia. And well, hopefully you'll get the budgets in the future to be able to do that. Okay, so I've got another question. Open. Whoever wants to pick it up, pick it up. What do you think the main differences are, if any, between the way the private sector and public sector prepare for space?
I guess I can sort of speak on that from a sort of a more government-funded perspective, because RAL Space is government-funded. We're very lucky in that we are not, we are given a budget every year, but we are not tied to making a profit as such, or whether it's with obviously commercial industry, it's a business. It's got to make a profit so that it can continue running and pay its staff and continue growing. Whereas with a government funded body, you've got your budget, and what you choose to do with it is up to you. You have to get the funding, obviously, from certain places for certain projects and things, but there is no entire responsibility to pay all that money back to the government. You have that money and you can put it into all the projects you want and get all the development going and everything. So it's the ways that there's the structure is, I think, between effect.
Yeah, I might jump in there at that point. Actually, it's a really it's a really interesting point that Hannah raises about the way that these businesses operate. And I remember going to the managing director of Airbus Defence and Space UK in 2015 and asking for money. This was money to do qualification work and work on AstroPi. And his response was, what's in it for me? What do we get out of it? You know, because he's built his life around business. Every pound they spend, they want to get some money back for it. And I had to say, look, what you're going to get for it is kudos and visibility. And, you know, how do you put a figure on those things? It's very difficult. And, you know, I think it's probably quite lucky that I managed to twist his arm and get him to put his hand in his pocket for things like that. But, you know, working as I do in a large organization like that, it's always about profit and loss. And, you know, I got a lot of friends in the UK Space Agency and work on some outreach programs which are funded differently. And it's a really interesting way to work, that you sit between those two things, and you almost have to write a business case for something in a way that you're almost like going into Dragon's Den. And that's quite a tricky thing to do, I think. And it's you know, if you're asking someone for money, they want to know what they're going to get for it, and sometimes it's not necessarily profit.
Yeah, maybe I can jump in on that one as well, because we are also very, very used to make a case for companies why they should sponsor us for these missions, because they also don't get anything. Mostly they get, of course, public outreach and a lot of press, which companies are happy about if it fits within their goal they are doing. But I think also it's quite a different thing. If you are a government organization like ESA, you have so many countries which are talking within ESA what to do, that you have strict rules how to do things, and you cannot jump on one thing which might be very interesting and very useful, but you just can't do it, because you have to go over all your country heads and talk with them and make a decision. So for private companies, it's much easier to go in one direction, because if, I don't know, Elon Musk says, yeah, let's go to Mars, he does it. And the people follow him, and it's much easier if you don't have, like, I don't know, ESA. How many ESA member states do we have now? I should know it, like 22 or something. Yeah. Okay, good. So it's a different approach, of course, and that's what it makes difficult for government organization, I would say.
Yeah, I would pick up exactly on that, and I agree completely with Olivia that it is challenging. Because of the structure of public organization, we sometimes aren't as agile. It's common with many public organizations as a company can be. But the flip side of that is indeed that it's easier for us to justify outreach activities or blue sky projects and things like that, because that in a way is what we're there for as a space agency. We're there to sort of try and blaze a trail and take the things that are maybe too risky for business to pick up, or what for things that there is no business case yet, and things like that. That's why we're there for. I think it's also important to say that there's actually a really blurred line between the two. Not always. I mean, sometimes you've got things like SpaceX, which are very much a corporate thing. But for example, between ESA and Airbus, or ESA and Thales Alenia Space, or any of the hundreds of other companies that we work with, there's a much more blurred line, where a lot of our projects, when we say they're realized by ESA, well, they're realized by the space industry, by business. Those are the people that actually realize the projects for us. And so it's a very symbiotic relationship there. So it's hard to say that there's a strict boundary between one and the other, I think.
Yeah,
Fantastic.
maybe just one sentence to that. I totally agree with Thomas, and I think it's also important that that we have government organization like ESA, and I'm a very big fan of ESA, of course. Maybe whatever. There's also the possibility for these industry which are working for ESA also to jump on certain aspects to different organizations and to work, for example, also with us for the Simulate Mars missions, or to work with also different companies. And yeah, that's probably one good thing that both is possible, working for ESA and working also for private things. But if we want to go to Mars, and I'm a very strong advocate for it, of course, I think also the big government organization probably would need to take more risk, and it's very hard to discuss and gives a lot of different implications, of course.
Yeah, I guess that's a very interesting point about risk appetite as well. Sorry, I just got muted there. Yeah, risk is quite an interesting thing. It always comes down to money and risk, doesn't it? It seems to be in the conversation. But I guess that's what makes the world go round, eh? So thank you very much. There were some fantastic points. I'm just looking in the chat now, and I can't seem to see any more questions. There's a lot of enthusiasm for AstroPi in the chat, I must admit. Yeah, any more final thoughts from any of the panelists before we move on to our next section?
I was just thinking about something Olivia said about going to Mars, and I often present the counter argument that going to Mars is not going to be easy, and I think Olivia's things that you're doing are proving that point. And perhaps it needs to be out, in my view at least, in the mainstream, that going to Mars isn't like, oh, we're going to go to the moon and just not get off. We're going to keep going towards Mars. It's a whole step change. It's not just going to be solved through engineering and science. It's going to be a whole lot of other things that have to be done. And just to make one point, I remember in 2009 when we were celebrating 50 years of Apollo 11, the air-to-ground radio was being replayed in real time, and I remember listening to the alarms as the astronauts were going down to the surface, and the fact that they had almost real-time comms with the Earth to fault find things. And you overlay that with a mission to Mars, and you think about those humans going down to Mars. They're on their own. They are literally going to have to fault finding and doing everything they can on their own. And they're going to have to. They cannot ask for help and expect it back suddenly. They're going to have to fault find and do all those things. And all those skills, all that training has to be done in the time between now and sending humans to Mars. And I think this is a great goal, and we have to embrace everybody to come on board and try and find solutions to this, because things like what Elon Musk are doing with Starship are fantastic, and he's showing the fail fast mentality, where you test something and show it exploding and go, well, we learned from that. But there's very little chance of Starship flying to Mars on its next flight. So there's a whole load of steps that need to be taken in between to get us to sending humans to Mars, and it's a journey I look forward to seeing happening. And things like what Olivia doing in the background of perhaps not seen as widely as they should, because these are all things. And I can just imagine that being in those analog suits, walking around in the desert, is really, really hard work. And I can imagine the lessons learned, the feedback you've got from that they need to be pitched at a very high level to people who are planning on going to Mars, because they're going to be critical things that you're finding out with those things.
I think I'll pick up from John for my closing, because that actually gave me some thoughts as well. And going to Mars, as you say, it's a fantastic goal. It's very difficult and very far away. And I really want to pick up on what you said, which is that the diversity of the space industry, the number of things that we look at and work on, and very many of those things need to come together to get us to Mars. And I would encourage everyone listening, and you're already doing a great thing by listening and getting involved and seeing how wide the space industry is. Sometimes, yes, Starship is amazing, and there are amazing feats, but there are so many amazing bits of the space industry, from the little ones, someone working on some amazing software code, to going out and working on Mars analog in the desert and things like that. Then you've got things like a giant robot rover that's just landed on Mars and is going to fly its helicopter. We should celebrate the big projects, but I would really encourage everyone to celebrate the little things as well, because every little corner of the space industry is fascinating for me, and I'm sure it's fascinating for all of you as well. So that would be my closing thought, I think.
Yeah, that's a wonderful closing thought, Thomas. I would encourage also people out there who are not working in space and industry, but are really interested into space. there are possibilities for you also to get working in space. So you don't need to be a space professionalist to work for space and to bring also humankind forward to Mars, for example, or to the moon, to solve the space debris problems. There are a lot of things out there where people can help, even if they don't have the education. If you're not an engineer or something, I'm not an engineer, but I help with the Simulate Mars missions. And if you are out there and interested, and it doesn't matter which background you have, please get in touch with people you support. And there are ways to help bringing or preparing for space, as the motto would be for tonight. Yeah.
Yeah, I'd agree with what everyone on the panel has said there. Yeah, 100%. It's going to be a real challenge to get to Mars, and I guess from the perspective of my family, anyway, they don't know that much about it. So yeah, there's some of those people that you can talk to them and say, actually, it's a lot further than the moon. Unfortunately, it's going to take us about 7 months to get there, rather than just a few days. A week round trip and off we go. It's a lot further away, as John has said. The communication is non-existent in real time. Anyway, you've got a gap between 14 and 22 minutes sometimes of communication time that it will take to travel. So you really are on your own. It's going to take the best qualified astronauts and the most highly trained that we have, the best engineers, the best scientists, and the best of everybody to come together and pull that mission together, organize it, schedule it, structure it so that it goes as smoothly as possible. And that will take thousands of people working across all sorts of industries. And I think that's what's going to be really exciting when we finally pull it off, that it's going to have touched so many people's careers and lives, that they can say that they were part of that. So I do say that. Thank you.
That's fantastic. Thank you very much. Well, that's been an absolutely fantastic panel. We did have one more question in the chat, and I guess we've got time to answer it very quickly. A bit political, but as I say, we've already discussed money, so why not politics? Do you think ESA collaboration will be affected by Brexit?
I guess this is down to me to answer. It's a tricky one, because we do try and stay out of politics. We try and stick to the science and engineering. I think the main thing to say is that Britain is a member state still of ESA, and ESA is not directly connected to the EU. We do a number of projects together with the EU, but we were there before the EU, and we intend to stay for a very long time still. So in that sense, at least from my perspective, looking at the ESA world, I don't see a great change. The UK is very committed to space, which I think is a fantastic thing. I think it's a good thing when any country's committed to space. And they've repeatedly said that they recognise that ESA is a driving force in space for the whole continent, aside from politics. But if you just talk about the science and the engineering, that ESA is a driving force for that. So I'm grateful that despite Brexit, the ESA cooperation should remain somewhat untouched.
Yeah, and it's a really important message there that membership of ESA is not dependent on being a member of the EU. And it's a question I get asked a lot, and I have been for a few years now. And I think that, you know, people do assume that you've got to be in the EU to be a part of ESA, and you don't. And you know, there's some very simple things we can do to educate people with this and put a positive spin on it. That, you know, yes, as the UK, we've got a thriving space industry. We do a lot of work. And we give a chunk of money to ESA to be a member, but around about 80% of the money we give to ESA comes back to the UK in contracts to the space organisations that are here. And, you know, I'm really pleased that around 50% of that 80% comes to Airbus Defence and Space. So that money isn't going to this big bad EU. It's going into the pockets of the engineers and scientists here in the UK. And that relationship is really important. And I think that relationship is probably stronger than Brexit. I think it will outlive all the talk of Brexit, and we'll continue to show all the good things we can do when we work together.
That's fantastic. Once again, thank you very much to all of our panelists. That was an absolutely fantastic panel. We've got some interesting insights there on preparing for space. There will be a general Q&A session at the end, so if the panelists are still around by then we'll have time for maybe one or two more questions along with all the other speakers that we've got this evening. So without further ado, let's move on to some of the T-5 talks, and we are going to start off with Charlie, I believe. Charlie Blinsland. Are you ready, Charlie?
I am indeed.
Cool. Let me start presenting, and then as soon as I hit present, you will have 15 seconds per slide, no slowing down, no stopping. So let me know when you're ready, and I'll click the present button.
Yeah, go for it.
Right, off you go.
Hi, everyone. So I'm here to speak to you about two things. First of all, powering space, and second of all, impulse. It's going to take about 5 minutes. I've got about 50 minutes per slide and no stopping or no going back. So here we go. So quickly, who am I? My name's Charlie Bilsland. Nailed it on the pronunciation, Ryan, but I'll let you off with that. Background in consulting and entrepreneurship, and I come from only getting into the space sector in the past 2 years. I have a long history in adventure. What are we doing? Powering Space is a volunteer, not-for-profit organization. The whole point is bringing together people from across the space outreach world to learn from each other, share skills, and support each other. Why are we doing that? Well, because space outreach is hard. Holding conferences like this is really, really difficult to do the logistics of it, to do the planning. It takes a lot of effort. People need better support in that. And often what happens is you learn something from one conference and you need to apply it to the other. So how do we do this? One of the easy ways is a Slack group. We just bring people together in a Slack group and help them communicate. We're running a conference next month, and we also have monthly calls to go over different concepts or plans. So it was started in 2019, 2 years ago, originally to help new space entrepreneurs and for me to better learn about the space sector. We ran London Startup Weekend Space, which was a great success and launched 10 startups. And after that, it kind of languished for a few months until I went to ISU and I met some people at ISU, the other founding team, and all of us worked together on different projects. So I ran Space Pals with a friend and another guy ran Space Business Podcast. And we started to get to the point where we realized there needs to be better support for space outreach because we found no place where we could learn from each other. We were having challenges and all we were butting up against was each other. So that's where it came from. And our solution is to build a community of communicators. So able to talk about the challenges of space outreach. So what works, what doesn't work, how do we do it? And I like this rising tide lifts all boats because I learned that the moon was a big part in getting the Ever Given lifted off from Suez Canal. What is Impulse? So this is the conference that we're running on the 9th of April. I've realized at this point that there's no dates on it, but that's okay. It's the 9th of April. It's next Friday. Next slide. There's not really much there. So the first panel, basically I'm going to go through what we're going to talk about over the conference. So the first panel is around what is space outreach. So we've got Chris Welch and Marianne Mader. And this is space outreach education? Is it marketing? Is it PR? We're not really sure. It's kind of one of those ill-defined terms. We're doing 5 platform masterclasses across YouTube, Twitter, TikTok, Clubhouse, and podcasting. So if you want to learn more about a different platform that you're not involved in, we've got experts who are going to give you a 50-minute chat on how to do it effectively. We're also doing a panel around communicating across borders. So this is with Miranda, Nikita, and Herb. We've got another person joining. And all around, how do you talk at different levels to different people and through different generations? To back that up as well, we're running another storytelling masterclass. So this is these one after the other. So Danny is going to run us through how to shaping story for different platforms. So telling a story on Facebook is different than on Twitter. And Nicholas is going to talk us through how to talk to different audiences. So tech literate versus non-tech literate, for example. We're also going to have plenty of options for networking. So Ryan Laird is going to be supporting us on that. And there'll be plenty of places to chat with other people about what works and what doesn't work. Because the whole point of a conference is you want to be able to talk to the people that are your peers. So if you're thinking about it, why should you come? Well, it's a great chance to learn from the best. So anyone else who's doing something fantastic, you can meet and chat to other outreach professionals, and you can learn how best to tell your stories. So that is the address, Powering Space powering.space/Impulse 2021. There's still tickets. I think we have another 40 tickets to go before we're sold out. I don't really have a lot more to say on this slide, but I've got another few seconds to burn. There we go. Why should I join Powering Space? Well, this is what I really want to push, is what we're wanting to build is professionals who are interested in space outreach. What we think we can do is build a real powerhouse of people who care about this kind of stuff and want to make a difference. It's not going to Mars, but it should make a difference in promoting and helping us all communicate space, because I think that's one of the things we struggle with the most as a community, is effectively talking about space. And we want to make that place where you can help best learn how to talk about space. So thank you. That was my T-5.
That was absolutely fantastic. Thank you very much, Charlie. Right, so next up in the lineup, we have Vicky from Vicky Video. So give me 2 seconds, Vicky, and I will get your slides up and ready. Actually, Ryan, do you have Vicky? Oh, it's just come through. Sorry. There you go. Okay, and let's present my screen. And Vicky, are you ready for this? 15 seconds per slide. No slowing down, no stopping. I think you're on mute, Vicky.
How about that?
Perfect. Right, let me know when you're ready and we'll kick things off.
I'd just like to say that was a great chat then, Charlie, and I'll definitely be there for your presentation next week. So I am good to go.
All right.
Woo!
3, 2, 1, away you go.
Hit it. Okay, welcome to the Space Tourism Society UK chapter. This is the networking group for Space Mavericks, and it's completely brand new. Next slide. There we go. So it's a US organization founded in 1996. The Space Tourism Society is the first organization specifically focused on the space tourism industry. We now have chapters all over the world with a brand new UK branch. The space, oh, my thing's in the way, hang on. Me things covering it. There we go. The space tourism industry officially started on April 28, 2001, when businessman Dennis Tito lifted off on a Russian rocket in a Soyuz capsule to spend 7 days on the ISS. So this is our wonderful founder, John Spencer. He is an award-winning NASA space architect, designer, and developer of several space and future theme parks and attractions. On the board of governors, we have got some rather well-known faces. Dr. Buzz Aldrin, Dr. Robert Bigelow, founder of Bigelow Aerospace, and Dr. Peter Diamandis, chairman of the X Prize Foundation. Speed read this list of millionaires or possibly even billionaires. Take a look at the names there. All these amazing people have started or invested in space enterprise or space tourism ventures. The space tourism business has been by far the most profitable space business to date, with a 95% or plus profit. We feel the space tourism industry will be the fastest growing space industry, with the most people in space for several decades. Space themed tourism on Earth is massive. Almost as many people visit space themed facilities as visit the 2 Universal Studio movie and theme parks. Lots and lots of people go. Let's go cruising. We believe that exploring the beautiful, sensual and futuristic aspects of space tourism is essential if we are to gain the interest and support of the public and the finance community. We are focused on modelling this new industry after the highly successful cruise line industry. Imagine floating in zero gravity while gazing at our beautiful planet as our beautiful planet Earth majestically rolling by your viewport. Millions of people from around the world would love to have such a wonderful, life-enhancing experience. The Society is now capitalising on the resurgence in space travel. We conduct major research and promote our findings and plans to the world. The Society will strive to become a major communications hub for the media and the diverse and growing interest in space tourism. So, welcome to the brand new UK chapter. Fantastic field trips coming soon. It's not your standard networking group. We're going to throw together lots of people from different sectors in intriguing and beautiful locations. So field trips, for example, may include a visit to the zoo to be inspired about alien life. What planet are these from? As it happens, they're from Titan, and those are wings, not ears. We could go to aerospace museums to refresh ourselves with the splendour of the wing, and who knows what ideas may arise as you gaze at a vintage aeroplane. Yes, looking forward to organising these trips. Field trips may involve visits to geological marvels. This is where I live on Anglesey. It's a psychedelic landscape, Paris Mountain. Imagine a day spent here mooching around with fellow space mavericks. These are not going to be your average networking meetings. Or we may visit concept hotels and cruise ships. That thing on the right is actually scheduled for production fairly soon. That is a beast of a cruise ship, wind-powered. The best way to predict the future is to invent it. Thank you for that quote, Alan Kay, inventor of the overlapping window interface for your laptop. Good work. In the meanwhile, I'd like to invite you to the Space Tourism Conference on April the 28th, 2021. It's the 20th anniversary of liftoff of the first private space traveller. If you get your tickets for this year, it will also give you access to the real event, which is happening next year. I am Vicky Duncalf. I am a space sector video blogger, and I run Star Factory Productions. A Star Factory is a vibrant place in space where stars are made. It's also where we make your space business famous. So do help me build the society from scratch. Drop me a direct message on LinkedIn and become one of the founding members of the Space Tourism Society UK chapter. You are all invited. It'd be great to have you along. There we go.
That's fantastic. Thank you very much, Vicky. I'm sure I'll be looking into the Space Tourism Society. It sounds like there's going to be some fantastic and interesting trips ahead once COVID's out the way, I'm guessing.
Yes,
I know. Certainly I'm desperate to get out and enjoy the world and see the museums and go to a place like that again. But one day we will, I'm sure.
Thank you.
So I'm just setting up the slide transitions for the next slide. And then we, let's see, where are we? So next up, we have got Nischel talking about the new moon rover concept. So are you ready?
Yes, sir.
Okay. Okay. Right. 3, 2, 1. Take it away.
Okay. So whenever we see about the rovers size are really, really larger than we think. As we take the moon rover, Curiosity, and Perseverance, they are really, really large. And my new idea is of making a rover which is a shape of a small, or which is a small, with taking the advantage of the several planets' gravity. Next slide, please. So the main idea is using the gravity of the several planets, and these are the contents. And next slide, I will be explaining these out in the next slide. These are the proposal contents, and I would be explaining it. Next slide, sir. Okay, so before starting, I would like to introduce what we have in the history of the moon rovers. So the first moon rover was Linkoda-1, the first moon rover made by the Soviet Union, and it had landed in the moon surface in 1969. And the second is the same, the Lurken-2, and it had also landed by the Soviet Union in 1973. And in the following rovers are made in the history, and these are really, really heavy. And U2 is made from the Chinese government, and it has landed in 2016, and it was also too much bigger than we thought. And U2 is had also followed Chinese rover, and Pragyan, as you know about Chandrayaan-2 rover, sent by Indian Space Agency, and it was also too much bigger, and the cost is more than 40 billion. And what is my idea? So it is a simple idea. What we are seeing, it is a it seems like coronavirus, I think. So it is a ball-shaped rover, and it has contained a simple spring kind of. And what is the thing we are using? We are using the gravity, and we are the humans making the more efficient and effective things. And we are using the gravity of the moon. So moon has 6 times lower gravity than Earth. So we are using it. So there are some kind of management approaches, and this what we be using in that rover. So the rover, we don't have much more fund for the rovers, and the rovers mission are so much expensive, like billions of dollars. So in the Curiosity rover costs $1.5 billion, and we have the time to change our mind and take the cost of the rover to $13,000 only. So nanotechnology is our main concept, and the main idea what kind of facilities this kind of rovers can give. And software designing and hardware requirement, I have listed out some of the software and hardware requirements, sensors, and what kind of thing we need in that rover. Next slide, please. Okay, these are some kind of software I cannot explain in the moment. Okay, next slide. Okay, these are also some kind of quantum computing and artificial intelligence which we can put on that rover for exploring the moon's surface, as the moon hasn't been explored much more. So the main concept is that rover bounces in the moon surface in some kind of rocky kind of places, and for the sandy places, that rover expands like something differently. So the main is proposed cost. So we are making the rover with low cost, and we need to be wary of the cost. So this is the overall for the first time manufacturing. So it is about $1 million, I think. But if we make this rover, we can change the future of the moon exploration. So these are the questions. No, change the slide. This is not important. Okay, the main conclusion. The Mars is the future planet of us, and we are fast moving to the Mars, and we have to make the rovers as much more cost effective. So this is my contact, and if you need my idea, then I can give anybody. So the main idea is making a rover which is very much cost effective. Thank you very much. If you need it, call me.
That was fantastic. Thank you very much indeed. So next up we have our two grid talks. We're starting to start off with Narayan. Are you with us from SatSearch?
Yes.
Fantastic. Joe, feel free to present and take it away.
Thank you very much, Ryan and Ryan, for the invitation, and Remco, hi to you as well. Thank you. So my colleague Karthik was originally meant to give this talk, but due to some circumstances, he couldn't be here. So I'm pitching in for him. So just to give you a background, I had the privilege of organizing Asia's first SpaceUp back in India in 2012, or I think end of 2012, December 2012, as I remember. And I was in contact with Chris Radcliffe and then organized it. It was the first edition of SpaceUp in Asia. And we had about 300 participants in the first event. And that's where I also met Karthik for the first time, and eventually started a company called SatSearch. So of course you can meet cool people at SpaceUps and start companies with them. We are one of the examples of having met each other at a SpaceUp and eventually starting a space company together. So having said that, SatSearch is a marketplace based in the Netherlands, and we're basically helping engineers find components and so on. But that is not the topic of the discussion today. It's more about how do we build inclusivity and diversity in the space industry. And having educated in 4 different countries myself, and having worked in 3 different continents as of today, I can tell you by my own experience that this is an extremely difficult topic in especially a sector like space, especially because of basically governments funding most of the space activity, which means that it is only fair that taxpayers in that particular country finance only employment of those citizens. So of course, when people ask Elon Musk, can you employ us, Europeans or Indians or Chinese people or Japanese or whoever it is not reasonable if governments sponsor space that non-citizens get employed. I can vouch for the governments in that course, because it's the taxpayers' money that is being funded, and it's only fair that the taxpayer funds their own citizens and so on. So I am in that quarter as well. So the question is, how do you actually navigate around it and make sure that you can still have diversity and inclusiveness and everything that that goes with it, despite having these constraints in the space industry. And for me, it's one of the examples that I wanted to bring this in this particular talk is something like the rise of the CubeSat and the new space world, because as you've seen it in the last 20 years, CubeSats have really enabled, and nanosatellites have really enabled 50 different new countries possibly to enter the space sector. And the question is, how is that possible, right? So you reduce the access to space, and then you basically give a bunch of countries and universities and everybody else a possibility to then invest into a space program and so on. So now the question is, about 20 years ago, if you had to fly a CubeSat, you had to spend $150,000 per kilogram, and possibly spend $500,000 or $1 million to just put something together that fits in a 1 kilogram block of electronics. And then that was almost as if you could, basically use that money to build a university in a country like India for the same amount of money. So, which means that, it really is not something that is sustainable for many of the countries in the world that you could start something like this with such high costs. So people would rather say, I want to go build something else for this amount of money than invest in space or so on. And even if you did do that as a government, where many of the governments have chosen to sponsor universities in many of the countries around the world, which don't seem to have a space program or a space agency. Unfortunately, the problem that I see is that people do these CubeSat programs or are involved in these projects, but unfortunately, at the end of it, it's a university project, and after that, you spend 3 or 4 years building your capacity and building your skill set in the university and getting involved in the space mission and being very passionate about it. But the road for you at the end of it is a cliff, because there is no industry for you locally to participate. And I've seen that with thousands of people, even in a country like India, where we do have a space program. But unfortunately, the number of people employed in the space program is possibly just 20,000 out of, when you have a 1.3 billion people, and you have 20,000 jobs in the space program, possibly just 300 to 400 people being employed in that, you could have a competition of 2 million people trying to get into 300 jobs. So the odds of that is very, very, very difficult. And at the end of the day, at least we have a space program, and many of the countries, for example, around us have just started it. Like Bhutan has a space program recently, and Sri Lanka has built a CubeSat, and Nepal has built a CubeSat, and so on. So the question there is very interesting as to what is diversity and what is inclusiveness in the space industry, because I've heard the last few panels and people being very passionate about doing analog missions and doing extremely complicated hardware to Mars and everything else. And I think you have these very large divides in communities of people, and especially that comes from probably not having to know every single community that is trying to do space and looking at how do you kind of enable them. So there's two parts to the solution that I've thought about this, and I encourage everybody here to think about it more and look at your own ways to come up with solutions. But for me, the one part of it is that is probably not solvable in the current roadmap in the next 10 years at least, is that of course, governments in various parts of the world may not be interested in space politically or even economically, may not be capable to invest in upstream part of the space. But I think we, as many of the countries, including Europe, US, and other parts of the world, should rather encourage people to also get into the downstream segment of the space industry where the investment is very little. But the cultural problems of those countries may not be fully understood by people in the US or Europe or so on, because those are cultural and economic and socioeconomic problems local to those geographies, but have the potential to be solved using space technology. As an example, for example, I come from India, so we have 125 million families that are in farming, and about 30-40% of them still depend on non-institutional financing, not through banks, just by money lenders at very high interest rates of like 2% or so on, right? So you could have European satellites and European cloud infrastructure and European engineers giving this infrastructure of satellite data and cloud and all the other solutions around, telling people how predictive, how their farms are doing and have been doing for the last 10 years, and tell banks in India, for example, how productive these farms are, and do a risk mitigation scenario for them and create the infrastructure for them to tell local farmers in India then can then benefit from banking infrastructure, because the banks have the enough information to then do risk management for these lending, for which they don't have any data for the last 10 years because they have not collected any, for example, right? And this is the case scenario for many of the African countries and several other countries as well. So unfortunately, I think there's very little thought in this kind of a direction, where people tend to form clubs of each other in micro geographies and microcosms and cities and countries and so on. But there's very little cultural understanding of space and the problems that space can solve across the world. And that it has a direct impact on inclusivity and diversity with respect to what the community is today. So that having said, I also think that there is no such institution, somebody may correct me if I'm wrong, that actually tracks diversity and inclusiveness and has metrics and can look at it in a form that people can transparently say that this is how you measure it in the space industry, not just for your country, your organization, and not just saying, oh, I have 30% women in my workforce and whatever in that fashion, but really looking at it from kind of a global perspective and creating a framework that actually works for everyone and can actually push people to do more, not just in their own backyards, but also cross country, globally as such. So I would encourage anybody to pursue such a framework that people can transparently look up and also can actually use that to systematically update. And then for me, I think culturally updating everybody on problems and then trying to enable people to solve that and giving people tools to solving it is one way that I see as the pathway to really creating a diverse and inclusive space community. So that having said, I don't want to take up much further time. And if there are any questions, of course, I'm happy to answer it. So again, thanks to all of you for having us here and giving us an opportunity to address this particular viewpoint.
Thank you, Narayan. So I'm just looking if you have any questions. Yeah, so there's, I think John Swift was saying attended ESA's downstream for sustainability event last week. So yeah, downstream particularly is a very sort of diverse part of the space sector there. And I don't know, actually, I don't see any particular questions, but would you say there's any particular parts of the space sector where they're more diverse than others, and what areas maybe need to be improved on? I know, for instance, there's in the UK, there's been a space census, has been launched, actually the results of which are showing some parts of that, more putting numbers to that, which has been brilliant. But do you have them on your side for Sat Search?
I'm going to just take I saw Remco's hand go up, so I'm going to ask him to also go ahead, and I'll probably address both of them together.
Okay. Well, real quick, first of all, we all noticed your background. You definitely win the best background of the conference award, if we had any. That's awesome. You have to show us the link where we can all get one for our next webinar. Secondly, your comment about downstream, I mean, that was part of the conversation that we were having on the YouTube feed as well. I think you're absolutely right, and there's so little understanding in countries, developing space nations, if you like, that the opportunity really is in the data. Everybody wants to build rockets and satellites, but most of the jobs and most of the opportunities and most of the money, honestly, is in downstream, in data, and yet so few people understand. So how do you think we as space communicators can help create that awareness that the opportunities are there, the jobs are there, the money is there, even in countries like India and all the other countries that you mentioned?
Yeah, it's a very, very good question. And I actually did my PhD on this particular topic, looking at it from a supply chain point of view and solving problems in agriculture, energy, and banking and others. For me, the clear-cut answer is very simple. You actually have to remove the space people in the process and get people who are specialists in anthropology, societal studies, agriculture experts, and so on, and who really understand not just the technicalities of the place and the geography that you're talking about, the history of it, but also understand people, they understand the cultural intricacies out there. And then, you can then look at what is the possibility of technology being involved in it, and involve the technologists, because at the end of the day, any social application that you are going to build, for example, I know a company in India, for example, that is helping small fishermen. About 13 million people in India depend on fisheries, so just have jobs in fisheries. So they have small boats, unlike larger corporations that have large trailers. And so, for example, this company in India has a very small Android app where they charge like €2 a month to this fisherman. And they give the fishermen weather updates. They give them potential fishing zone information. They give them access to the market where they can go sell the fish. And the outcome is that the farmers, they actually keep track of how much fish they collect through the app. They look at where to go and collect the fish using the potential fishing zone information. They're safe in the waters because the weather updates are given to them. They're also safe from borders because they don't cross the Indian waters and get captured by other navies, for example, and they're safe in that sense. And also the outcome of this is that the amount of diesel they consume, those small boats, it drastically reduces by 50%. So you're actually impacting, have a lesser carbon footprint overall as well. So there are many, many, many such stories out there that need to be told. And this is one community and one geography, right? Somebody can take this and tell, empower people in other parts of the world, like Philippines or maybe Indonesia or wherever, right? Who have massive fishing communities, and they can do this. And this app is also helping, the government to keep track of overfishing, for example, and they're also trying to share that information to maintain the sustainability of fish and so on. So there are many such stories to be told. The question is, are we reaching out to these people who are solving these problems? Are we highlighting them, and are we trying to bring them into the limelight, where it's I think everybody will be interested in stars, in astronauts, in moon and Mars and everything else. And it's very hard to tell the stories of these kinds of things where people are, solving problems in a different part of the world in a different fashion. And those stories also need to be kind of told in the same fashion that we tell stories about getting to moon and Mars.
Thank you. Easier said than done, but yes, I completely agree with that. Yeah. Thank you very much.
All right, thanks.
That's brilliant. Thank you. And now, sadly, our last grid session and session of the evening, for that matter, we have got Dame from the the Mars-Moon Astronautics Academy and Research Sciences. So feel free to present and take it away.
Are you sure that person is here? Because I only see the 6 of us.
Yeah, I think she's dropped off. Okay.
No. You're right. Okay. So, unfortunately, Sat Search had the pleasure of, it seems, being the last talk of the evening. So in that case, I would like to thank everybody who's presented. I'd like to thank the panelists again, and of course our sponsor, HE Space. And again, reach out to them. You've got their details in the chat and on the slide, or Google HE Space if you want to find out how you can prepare your career for the space sector. And lastly, I just want to draw your attention. We have a date for the next SpaceUp Live. It's going to be on the 8th of July, 2021. So put that in your diaries. We don't have a theme yet, so we will announce that in the very near future. And as always, if you want to present a T-5 or a grid session, then do get thinking now. And obviously, in the next few months, we will open the call for proposals for that. I'd just like to thank everybody again for watching and for joining us. And any final words from Remco or Ryan?
No, thank you. Thank you both for helping in the background while I was doing a lot in the background there. But yeah, it's been a really interesting event. I think we've had great panelists and great sponsors and keynotes. So thank you all for all your inputs there. And yeah, we hope to see you again on the 8th of July. So yeah.
Yeah, brilliant. So thank you very much, Ryan and Ryan, for organizing this 4th SpaceUp Live, and I'm really thrilled to see that the 5th one is now in the program, is now scheduled. I was really hoping when we did the first one that it wouldn't come to such a long line of online events and that we would be able to go live again, but I'm sure we'll get there. I had my first vaccination. I hope many of you have had your vaccination, will have your vaccinations again soon, so we can go back to in-person events. But until then, we keep you entertained through SpaceUp Live. And thank you again, Ryan and Ryan, for organizing this one and for keeping the SpaceUp spirit alive. So thank you very much.
That's fantastic. And this is where we leave you. And as I say, don't forget to look up at the stars, dream about space, and think about how you can prepare for space yourselves. So thank you and good night.